cool. Put you up there. Okay, here we go. I'm going to try my best. So Pail is this thing I've been hacking on. It's a key value store for DAGs. It's a bucket for DAGs basically, and it kind of optimizes reads by reducing kind of link traversals within the DAG when it's retrieving a value for a key. It's also pretty good for writes because it only shards when it absolutely has to, so it doesn't have to do loads of work. It's kind of fun. Just so you kind of understand the scope of it, Pail manages the part of the DAG that's responsible for tracking user keys and their values. And the values are always CIDs, and usually, obviously, these CIDs link onto other pieces of data like images or documents or whatever. But Pail is only concerned with this part of the DAG, which is managing the keys and the values. So when you mutate the Pail, it generates a diff, and the blocks that were added and removed come out of that diff, as well as the new root CID. So when you put a value, you give it the current root CID, you give it a key and a value, and then it gives you back a diff with a new root CID, what blocks got added and what blocks got removed. The same sort of thing for deleting. You get the idea. And then the whole plan is that you can take these additions or removals or whatever and kind of upload a car to web free storage. And then like this is super small because it's only, it's not the data for the documents. It is the just the tree information, the bare minimum stuff that had to change to create a new DAG. Anyway, Pail is a library, JS library, but I also built a little CLI tool that we can use to see it in action. So I'm going to try demo now with a different screen, if I can figure it out. Here we go. Right. Okay, you should see command line now. Cool. All right, so Pail it's just this command line utility. The main function is Pail put, and you can just, like I said, put a value, which is always a CID for a given key, and the key is just like a string of whatever you want. So we can do something like Pail put, and our key is going to be ABCDEFG, and our value is just a CID, and it doesn't matter what this CID is linking to because we're just talking about like the keys and the values at the moment. We don't care about the data. So I can put this in, and then Pail returns us a diff, and this is kind of pseudo diff thing with placeholder ATI things because it's not right at all. But you kind of get the idea. What's happening here is these first two lines of the diff are this is the root, the previous root that got removed, and this is the new root of the DAG. And so this is the CID of an empty Pail or an empty shard because everything is shards in Pail. And so, yeah, we got a new, after adding this particular key with this value, we got this new CID for Pail. And below these ats is the individual blocks that got added. And so because we're changing just the roots shard, this isn't super fun. It's the same as this, but if you happen to be mutating something that's in a deeper shard, then you'll get more blocks here, and we'll see that a little bit later. Cool. And so then we can put more keys in. So let's put something else in there. And what I did, because it doesn't matter what the actual data is, I just made like a little tool which generates a random CID here. And so what this will do is just put a key called something else with a random CID. Doesn't matter what that is. So I can put some more in, and you get back more diffs. So some foo things, put some food in, and I put some foobar woozes in, and you get the idea, right? So when you get a new CID, the next time you put something in, that new CID becomes an old CID and gets removed, and you get a new root CID for the DAG. That's kind of fun. And then so you can put stuff, but you can also do like a Pail ls to list out the things that we put in. So you can see we've got our keys here and the values. And we didn't put them in this order that they appear here. You'll notice that these are in lexicographical order for your viewing pleasure, but mostly it means that what the users can do is the users can define their keys to essentially allow them to specify the sort order of stuff. And then the really cool thing about Pail is you can do prefix matching. So you can list out keys based on prefixes. -p is shorthand for prefix. So you can list out all the keys that begin with the string foo, and it will just list out the 3 of them here. And I can do foob and get 2 of them, because obviously food doesn't begin with foob. Cool. So that's listing out keys with prefixes, and then like with prefixes, what you can actually also do is have like cursors and traverse through the data from a particular point. And what's kind of cool is that you don't have to know the whole DAG to be able to traverse through it. You don't have to read from the start. You could just read through the shards till you get to the bit you want to list out, and then list that. And then, so this bit is cool. You can actually take a look under the hood at the tree, the DAG that gets generated by Pail. So DAG tree, Pail tree will give you back this kind of listing, where like the yellow ones are actually blocks, and they have a CID, and that's why they have a file size associated with them as well. So we've got the root shard here, and then in this shard there's some keys and values, which are the keys which correspond to the keys that we added up here. And their values, which are just random CIDs, so nothing to worry about there. This is kind of boring because we're just working with like the root shard. What Pail does is it only shards when the block kind of exceeds 512 kilobytes, and that sort of avoids unnecessarily having to traverse through the DAG. You can, until it gets to 512, you can just keep adding stuff to it and read stuff from it. It just means that it never gets too big, that there's loads of stuff to search through, so you can read stuff out of it quickly, but it also means that you don't shard too often, so you don't have to do loads of traversals. So we can make this exciting by adding a key and forcing a shard, and we can specify max shard size to do this. So because this block is 259, or the shard is 259 bytes, when I put this key here, which I'm going to call foobar balls, with a random CID, I can specify the max shard size to be 259. And what will happen is Pail will try and put this key in and find that the block is too big now, and so it will have to shard. So I can put this in, I get back a diff, and in this diff, look, we get, because a shard has been created, we actually get multiple blocks that have been added in the diff output. And then if we look at tree again, woo, look at that. We've got a shard, another shard here even, and this is interesting. So what we've got here is like a key called foobarb, which doesn't correspond to any key that we've actually added here. But if you add on like as and oz, you'll get 2 keys, which are foobar baz and foobar boz, so that's kind of how this works. So what happens is that when the shard size is exceeded, what Pail does is it needs to create a new shard, and it does that by finding what I'm calling like the LCP, or longest common prefix, and it takes the key that you're trying to insert as a base. So in this case, it's foobar boz, and it works backwards through it until it finds another key. So if I look at our listing here. Let me just do a listing here. So it worked backwards through here, and it found that that foobarb was common with this key as well. So no others, but so it just meant that these 2 keys, it could be like with more data, then it could have matched like multiple keys, in which case they would have gone in the shard. But what happened here is that it matched against foobar baz, and it made a shard with those 2 values in it, which is kind of fun. Cool. And then so we can do this again. We can make it even more interesting if I put a key called foopi, and max shard size 258, because our shard size is 258 now. What will happen is it work backwards through foopi and actually find that foo is the common prefix between this one and this one and this one. And so what I'm expecting is like a new key here, which will be foo, and then like a barb, which will be this shard, this existing shard, and we should have bar woos. We should have a key called D. But yeah, anyway, so let's just show you that because it's better to see it than explain it. So we've got this key and we've got Barb, which is the existing shard that we had. This hasn't changed because it's got the same, so C3A, it's got the same keys in it as an Oz. It's got Barwoos and D and PEY, which is a Foopy. So that's our tree now. Kind of fun, huh? Cool. So we can do we can just get values out of Pail as well. Pail get food and just give you back the CID that you asked for. You can also delete stuff from it, like delete food. You get back a diff when you delete stuff as well because you've mutated it and it has to propagate that all the way to the root. And then we can, if we do list, obviously you don't see food there anymore. Cool. All right, fun times. So if you, okay, let me tell you about this. You might know about it, you might not. But if you've got like a computer that's like Linuxy or Mackie, then you might know, or you may not, that there's this file called words, and it's just got loads of words in it, like a lot, like 235,000 words, and that's kind of fun. And what it is like it's a dictionary from the 1800s or something, that is like it's just old, and it was under copyright, but the copyright lapsed, and this is 1993, so it's really old. But you know, there's lots of words in there. So what I did was I created a Pail with the keys are the words and the values are the CID of that particular word. So so that's kind of fun. And so if I go into scripts words, I can do like a Pail ls and list out all of the words in that Pail, which is, you know, quite a lot. 235,887 of them, kind of fun. But the cool thing about this obviously is like the prefix stuff. So I can do that -p bat, and I've got 179 of them, and they start with bat, obviously. When I was doing this before, I particularly like this word Battyphone, which I thought might be like a Batman thing, but actually it's like a clarinet or something. But anyway, so you can obviously get any particular key that's in there out, just, you know, get it. This is pretty fast, which is super cool. There's also proper names, which are like common, like just names of people, like just names. And so I put these in a Pail, and you can list out these. And there's only 1,308 of them. There's not lots, but it means that you can do like a tree and get like something that you can actually sort of look at. And so this is sort of to give you an idea of like what a Pail might look like when there's a little bit more data in here. Which is kind of fun. And then we can go all the way up to, I don't know, what did I do before? Sabrina, Sally, and Samuel are keys that are in here. But yeah, you see we've got some shards. Yeah, it's kind of big, but you know, not loads. So yeah, anyway, so that just gives you an idea of what a Pail bucket looks like with a bit more data. All right, real quick, I've got just, here we go, go back to here. I got some FAQs, some questions that I thought might be frequently asked. So why do we need a bucket abstraction? Well, CIDs not super recognizable to humans. They can see them, but obviously, well, I can't figure out. I don't know from looking at a CID what data is behind it. Find it quite difficult. Ironically, humans often need to actually identify the data that's behind a CID. So that kind of sucks, doesn't it? So it would be nice if there were something that you would allow you to name something like this. And all data storage services allow you to name your data, like S3, like R2, like, you know, Dropbox or whatever. You can name your data. It doesn't have to be CIDs, and we currently don't allow that. Why don't we just store a name with the upload? Well, we kind of do at the moment in web3.storage and NFT.storage. We allow people to specify a name for their upload, and we store it along with their data. And that's kind of problematic because the name is separated from the actual data that's referring to, and it's stored in our database, and it's centralized in our database because we store it, and that sucks. And it's also not scalable because when we've got millions and millions of uploads, we end up having like problems with, like, if people want to list out their things with a prefix, and they can't, because database literally can't like pick out that many things quickly enough, or do any like ordering operations or things with them, because there's just too much data. We can't do it. So pushing that problem onto the users, or giving them a way of doing it themselves, and storing that data with their other data is super fun. Why would I not just use UnixFS sharded directories? I did consider just doing a hacky version of this really quickly, using that, and you could. It's fine. It's complicated. It involves bringing in DAG-PB and protobufs and UnixFS encoding stuff, and then like dealing with HAMPs and stuff like that. It's just complicated, and I kind of didn't want to do this. Like Pail depends on DAG, CBOR, and multi-formats, and that's it basically. So I just wanted something simple that would kind of work. But the primary reason really is that I wanted this prefix matching thing. I didn't want to read the whole shard to be able to list out some parts of it. And prefix matching, and also being able to cursor through it and paginate through stuff really easily without having to read from the start of the whole shard, which I think from what I gather with HAMPs is tricky. I also wanted to be able to use slash and keys, and also minimize like block traversals, and just dynamically shard when it's absolutely necessary. And like HAMP, you put it in buckets, and then you have to traverse. Cool. And then so okay, really quickly, hopefully, how do we resolve conflicts? I thought about this a little bit. I've not got anything like CRDTs or whatever, but I thought this might be used in like applications where there's a shared bucket and two people are putting stuff into it at the same time. So it'd be nice to have like two buckets with like a base parent CID that got two different sets of changes, be able to get them kind of merged together. Well, I have a really quick...
you can already derive a CRDT from your diff.
Yeah. Nice. Okay. Well, okay. I don't know how to. All right. We can talk about that after. That sounds rad. All right. Cool. So what I've got here for you now is so what Pail does in this CLI is it works off a file in the current directory called pail.car. Hang on. Wait. I'm just going to go up a couple of levels so I can work with the one we were working with before. So if I copy this one to a new one, then I basically created a new Pail with the same content, and then I can tell Pail to use that new one by specifying path instead. And this is the same currently, but what I can do is I can put some stuff into this new one, like that.
Oh, you could have proved it was the same by diffing it.
Oh yeah, I could have done, couldn't I? Well, the diff will show that it's
Carry on.
Anyway, whatever. So I'm going to put like a bunch of things in here. So more, I've got my favorite GIF. Yes, this is dog. I'm going to delete something called, I'm going to delete the key foopy that we put in earlier, getting diffs out every time. And then what I'm going to do finally is there's a key called, the first key that I put in is ABCDEF, and I'm going to update it to be a CID that ends in rows now. So there we go. And then now I can list out the new car content. So we've got our new things that we put in, and as well as our updated one. And foopy is not in there either. And if I list out the current one, then it's slightly different. But then yeah, diff, right? So I can diff our current Pail against this new Pail that we've created, and it shows the blocks. But what's really exciting is that I can also specify that it shows me the key diff. So I can see that ABCDEFG alphabet, this got updated to that one that ends in rows. We've got a new key called bah. We've got a foopy, got deleted. We've got more got added, and our dog, yes, this is dog, got added as well. And then what we can do is we can say for our current car, merge in new car, and then that gives us a diff again, and stuff, and stuff happened. And then when I list out the current car, it now has all of that stuff in it that the other one had, like more something else, other stuff, and it's now the same as this new car. So 8 of them, and they're there, and that's that. One super last thing before I leave is one last FAQ. How do we track the route? So one consideration that I haven't really dealt with is we've got this bucket, the root constantly changes when you put stuff in it. How do we track which is the latest root of the thing? And that is the part that I haven't done any work towards yet. And my current answer is IPS, because
Yeah.
So that's
Yeah.
What you
So like, but you're sort of hinting though that there's kind of two problems with updating the name, right? It's like, it's not just how do you update the name, it's how do you handle the concurrency of different people trying to update the name at the same time, right? Like, how are you batching that stuff together? And like, one of the cool things here is that, like I'm saying before, you can derive a CRDT. If you just take all the publish operations that you're doing and send them to one endpoint, and it has 3 of them that are updating one single root state, it can actually look at each of those diffed cars and tell you all of the key changes as a CRDT and tell you if they conflict or not, and actually like resolve the conflicts that way. So you can get CRDT resolution right now by just batching these together when you do the mutation. But this is like something that, but what you're talking about is really something that we do need to productize, like in whatever we make our name product, because like when there's concurrent names coming in, like where do I send those concurrent changes to so that somebody can batch them together in the mutation?